Welcome to your Brisbane severe weather analysis for Saturday, November 29th, 2025. This morning's sounding reveals a significant severe weather setup developing across southeast Queensland. If you find this analysis helpful, please like and subscribe to support continued severe weather analysis. Let's examine this morning's 10 a.m. sounding. We're looking at a warm, humid air mass with surface temperatures at 27 degrees and dew points at 25 degrees Celsius. The mixed layer CAPE stands at 1741 joules per kilogram, which is substantial energy for the Australian environment. On the skew-t diagram, notice the blue shaded area showing minimal convective inhibition, meaning there's essentially no cap holding this energy down. The red temperature line and green dew point line stay close together through the lower levels, indicating excellent moisture. The lifted index of -5.1 degrees Celsius confirms strong instability. With 0 to 6 km wind shear at 16 meters per second and storm relative helicity values over 100 meters squared per second squared, we have the necessary wind profiles for organized storm structures. Now let's see how this transforms through the afternoon. The enhanced multi-parcel plot shows us the pink shaded CAPE area, representing the fuel available for storms. Notice we have three different parcel paths here: the blue dashed mixed layer parcel, the orange dashed surface parcel, and the pink dashed most unstable parcel. All three show significant CAPE, but the surface-based parcel has the highest potential at over 3,000 joules per kilogram. The small blue shaded area near the surface is the CIN, the lid holding everything down, but it's minimal. As we heat the boundary layer to the forecast maximum of 33 degrees Celsius, shown on the heated parcel plot, watch what happens. The heated mixed layer CAPE increases dramatically to 2885 joules per kilogram. The orange heated parcel path on the right side of the diagram shows how the warm surface air will rise explosively through the atmosphere. The pink shaded CAPE area expands significantly, while the environmental temperature and dew point profiles, shown by the red and green lines, remain unchanged from this morning. The supercell composite parameter increases to 2.39, and the significant tornado parameter reaches 1.06. This transformation shows why afternoon heating is so critical for severe weather development. Looking ahead to tomorrow morning, the machine learning forecast shows a complete shift in the pattern. By Sunday morning, CAPE drops to 682 joules per kilogram as the overnight boundary layer stabilizes. However, the 0 to 6 km wind shear increases to nearly 25 meters per second, maintaining organized wind profiles. The lifted condensation level rises to 1422 meters above ground, indicating a drier boundary layer. Storm mode shifts to organized multicells with rotation possible, but tornado and hail threats remain low. The significant tornado parameter falls to 0.13, reflecting the reduced instability and higher cloud base heights. By tomorrow afternoon, conditions become more interesting. The machine learning model forecasts CAPE rebounding to 772 joules per kilogram, with surface-based CAPE reaching 1049 joules per kilogram. The 0 to 6 km wind shear strengthens further to 29 meters per second, creating an increasingly sheared environment. The lifted condensation level drops to 923 meters above ground, a much more favorable height for severe weather. The supercell composite parameter climbs to 0.5, and the significant hail parameter reaches 3.52. Storm mode remains organized multicells with rotation possible. While tornado threat stays low, hail threat increases to low, and wind threat becomes marginal with strong winds possible. The 700 to 500 millibar lapse rate of 5.8 degrees Celsius per kilometer supports vigorous updrafts if storms can initiate. The hodograph reveals critical information about storm motion and structure. The curved wind profile through the lowest 12 kilometers, shown by the blue to yellow dots, indicates strong directional wind shear with winds veering from light southeasterly at the surface to strong northwesterly aloft. The 0 to 6 km bulk wind difference is 16 meters per second. The red star marked RM shows the bunker's right mover storm motion, pointing south-southwest. This means any supercells that develop will track toward the south-southwest, carrying severe weather in that direction. The 0 to 1 km storm relative helicity of 107 meters squared per second squared, combined with the 3 km value of 140, provides sufficient low-level rotation for mesocyclone development. The supercell composite parameter of 3.63 and significant tornado parameter of 1.53 both exceed thresholds for supercell potential, though tornadoes remain uncommon in the Australian environment even with favorable parameters. The atmospheric refractivity profile, or N profile, shows us the stability structure of the atmosphere. The blue line represents the Brunt-Väisälä frequency, essentially measuring how strongly the atmosphere resists vertical motion at different heights. Notice the elevated duct layer highlighted in orange between about 800 and 1200 meters, and the superfraction zone in yellow below 2000 meters. These features indicate temperature inversions and moisture gradients that can trap and enhance low-level moisture. The relatively high N values near the surface, around 400 units, show a very moist boundary layer. Above 6,000 meters, the decreasing N values indicate the drier mid and upper troposphere where storm tops will penetrate. To summarize, this afternoon presents a significant severe weather setup for Brisbane with heated mixed-layer CAPE near 2,900 joules per kilogram, surface-based CAPE over 3,000 joules per kilogram, 16 meters per second of deep-layer shear, and supercell favorable wind profiles. If storms develop, expect right-moving supercells with potential for large hail, damaging winds, and intense rainfall. The low lifted condensation level near 1,200 meters and strong instability support severe weather if initiation occurs. Always consult the Bureau of Meteorology for official warnings and forecasts. This analysis is for educational purposes only and should not be used as the sole basis for safety decisions. This analysis is provided by Distant Curve Remote Area Telecommunications. If you found this helpful, please like and subscribe to support continued severe weather coverage for remote Australia.